So hello and then welcome to this workshop from many different parts of the world. It's a very rich and diverse group of people. Very happy to be with you today. So what we are going to do today is, as we promised, we are going to work on a project, machine learning project, which is, the problem is very common and very generic problem, estimating house prices. Okay, so don't expect a so interesting problem for now. All right, but I think the promise is we would like to see how we can start from the very first step on developing a machine learning pipeline. First of all, cleaning the data sets, and then finding the best model if we can, tuning up the model, trying different models, finding the model, tuning up the models, and then agreeing on one model. So that is the body of the work that most of us have been doing, right? So when we work on machine learning projects, but actually there are things that we should do maybe before this step, these steps, or after. So for example, before these, maybe we need to prepare the environment, right, for what we are going to work on for the project. And after we find the model, maybe we are going to deploy this model, right? So, and these two parts, which most of the time we are ignoring or we don't focus on because we want to learn machine learning, might be very challenging. And I don't think we're going to have enough time to cover all these today. So that's why I'm thinking to continue with this workshop. But today I want to first begin with what we all mostly know about, the middle part of the machine learning pipeline, which is taking a data set and then working on this data set, finding the best model. And then I'm going to go back, maybe in the next workshop, go back and then, given this model, which we should be doing before even starting working on the model, but anyways, given this work that we did, preparing the environment, so that we know why we are preparing that environment. So next time you can first prepare the environment and then start working on your project. And then we are going to learn how we can deploy this model, first locally, which is going to be very simple. And then for that, maybe you might need to know some about HTML coding. And next, I am planning to show you how to deploy this at maybe two, maybe more cloud services. I'm going to start with Heroku. If you guys search for that, maybe if you wondered how you can deploy a model, and then you might have come across with some tutorials or workshops on how to deploy models at Heroku. And then maybe you might notice that it's not free anymore. So I think the minimum charge is $5 a month to deploy models at Heroku. It was free before, but anyways, I'm going to show it. It's very simple. That's why I want to start from there. And then we are going to work on AWS, how we can deploy a model at AWS. There are different ways of doing that. Maybe we can look at one or two ways of doing that. And then if we have time in the future, maybe we can work on some other platforms. Okay, so then what do you need for this workshop today? What kind of material do you need for this workshop today? I'm going to just one second. Yeah, Charles, I just saw your message. Sure, after the meeting. So these couple of weeks were really crazy. So after the meeting, we can talk. I'm going to share with you the file, the folder actually, that I prepared for you. The folder includes the data set and the picture of California, state of California. By the way, this project is the project that is described in Cachon's book, which I really, really like and enjoy reading. From time to time, I read that book. So it is the second chapter actually. He's talking about this project. So let me share with you the link to, just one second. Okay, so this is the link to the data set and also one image that we are going to use, the map of state of California. So if you could please download the data set and the image to your local machine. You can use, if you like, you can use, I don't know, Jupyter Notebook or Jupyter Lab. I'm using Jupyter Lab. Or maybe you can use direct the Google Colab, so they will work fine. I mean, I suggest using Notebook at this point. So let me share my screen and then get started. I hope during this time you can download the data set and the image so we can get started. Okay. So I try to divide the work into meaningful steps. So it's okay if you don't have these steps, it's all right. So later on, once we are done with this session, for the next session, I'm going to share this file with you too, so that we can start from where we left, okay? Again, I'm gonna do my best to finish as much as I can during this 2-hour workshop session today, but I am going to continue with this. Sure, the name of the book, let me, just 1 second. Let me give the full name. So that's one of my favorite books. 1 second. Just reading it, where it go. So it's hands-on machine learning with scikit-learn, Keras, and TensorFlow. The first part of the book is about machine learning. The second part is on deep learning. The author is, the last name is Ceran, not Keshon, Ceran. It's very similar to my last name, actually. Ceran, let me, I'm writing the last name here, okay? Yes. Hands-on machine learning. Okay. Okay, so let's get started. First of all, we are going to import the very common, again, I am starting from the machine learning pipeline from the middle part. So I haven't prepared the environment yet. I know that I'm going to deploy this model. I'm just focusing on the mid part that most of us are very, very familiar with. Okay, so let's sharpen our skills, and then I'm going to expand it to left and right. Okay, so let's import the common modules that we are going to be using. There are some modules that we always import, right? So let's import NumPy. Okay, and then I'm going to import pandas. Okay, and maybe import matplotlib. Right, so these are the three, modules that we are going to be using all the time, right? So yeah, we are going to have the recording of this session as a YouTube video, all right? So you can look at it later on. So let's run this and then be done with importing these three. We're gonna be using more modules later, but for now, let's start with these three. Okay, now let's import the data set. I'm sorry. Thank you for the correction. Pandas SPD. Let us now get the data set on the environment. Again, this part is also might be very tricky. So it's going to be very easy for now, but it's going to be very tricky if you are working on data sets that you have to collect from different websites, or you're going to pull from a database, or somebody might be giving you data sets from different folders. So your job is you are going to merge these data sets and then begin working on that. So we are stepping forward. We are just ignoring all these complicated steps. Again, I'm planning to, when I expand, I'm planning to write some functions where we can actually gather data sets from different sources, okay? But for now, I'm just going to import a CSV file. Again, all of us are familiar with these steps, so I'm just going to keep it simple at this point. So let's just read the data. from the folder that I shared with you. So read CSV. Now my data set is here in my folder, in my local machine. So yours is going to be in a different folder. So make sure that you are just importing your data set from the corresponding folder. So what I'm going to do is I'm going to just type, so it's going to be inside data sets. And then it is, I know that it is in housing, and then housing CSV. Okay, so let's say this is my data set, housing data set. So I'm reading the data set now. Again, this step, just one click, right? So simple. It's not that simple. Again, we are going to come back to this point, right? And then we'll try our best to learn about how we can gather data set. And this depends on what type of problem you are working. It's going to be different from one problem to another, one case to another. It's going to differ. There is no a single solution for this step, but I just want to show you a couple of cases where it might be really complicated actually to get the data set. Okay, once we get the data set, we are going to just look at the first 5 observations just to see how the data set looks like. That's what I'm going to do using this head function. Okay, so this is how the data set looks like. These are the features given to us, including the target variable. So it is up to us from this point on. Of course, after we observe and explore the data set, it's up to us to find out what additional features we can come up with, or what some of the features we can get rid of. Okay, it's up to us. And these are very, very important decisions. So for now, these are the features that I have. Here's the location on the coordinates of the houses, actually, it's not the houses, the district. And this is the median age in that district, the median age of the houses, total number of rooms and bedrooms, the population, number of households, the median income, median house value, and the ocean proximity for the houses. So our goal is predicting the median house value for each district. So that is our goal. So this is going to be our target variable. Okay, so this is the this is the data set that we have. We are going to explore this data set a little bit more just to have some good idea about how this data set looks like. So I want to know how many data points I have. Okay, how many data points I have. So yeah, total rooms. This is not a single, Orhan, this is not a single house. It is the total number of rooms in that district. So district is a larger neighborhood, okay? So let me see how many data points I have, and then whether there are some missing values, and also, I mean, what type of features I have. So for that, again, I'm just going to check, type info. So I have 10 features, and out of 10, 9 of them are numeric, and 1 of them is categorical, and I'm going to talk about these in a minute. And I have around 20,000, or let's say 21,000 data points. And as you see, I have some missing values in total bedrooms feature. So again, your data sets may not be as clean as this one. But this is just one example that we are going to be working on. And by the way, be very careful when you have just, so here it looks like all the data points for longitude or latitude or housing median age. It looks like there isn't any null value. So you have to be very careful. It doesn't mean that all the values for those features are actually meaningful, right? So I might simply put some number there which is meaningless. Somebody who was filling out the data set might have put some meaningless data, and that doesn't mean that we are not missing any data points. It's simply that there is some number entered, but that number is not meaningful. So we have to be careful about these issues. So I had a lot of cases where I had to go back and then figure out what was wrong with the data set, even though my data points are not missing. Okay, so now we are getting some ideas. So let's work on some techniques how we can actually assign a Boolean variable to categorical and numerical features. So for example, I have 10 features and then 9 of them are numerical, 1 of them is categorical. So if I want to create a Boolean array which is going to be false for all numerical and then true for the categorical. How can I do that? So it's just a very simple procedure, but you will see that you're going to be using this. So this is my data set. I'm just going to check its data types. Okay, so I'm going to check the data types of my data set. As you see, I see the data set. If it is an object in a data frame, it is that corresponding feature is actually a categorical feature. So what I'm going to do is I'm just going to create false or true values. Okay, if my data type is an object, it's going to be true. That feature will have a true value assigned to it. Otherwise, it's going to be false. Well, I can assign this to a new variable called categorical. So anytime I need a list of my features, whether they are categorical or not, I'm going to be using this variable. Okay, so it's just one way to note which variables are categorical, which are not. What if I want to specifically create a list of the variables which are categorical? Okay, I want to create a list of variables which are categorical. I can do the same thing for numerical. Again, there are so many different ways of doing this. This is a practice, so I just want to share that with you. So let's say I want to create a list of categorical features. Okay, so these are going to be, in this case, it's going to be only one feature, which is ocean proximity, right? So let's use a list. And what I'm going to do is I'm going to write a for loop inside. So I'm going to go over all the features in my housing data set, but I'm going to be focusing on the columns of my housing data set. Housing.columns, right? So this is giving me the list of my columns. So I'm going to be looping over the column names. Okay. And then if that feature is, let me go to the next slide. If that feature is categorical, I'm just going to write that feature here. So let's see, feature. If that feature is categorical, then I'm going to say it's going to be, I'm going to check its data type. If it is, I'm going to be using capital O. You can use object like here. You can type object right there, like here, or a capital O string like here. So they will work. I tried them. They are working. So you can try yourself. So feature by feature, I'm checking if the data type of that feature in that data frame is object or not. If it is, then I put that feature into my list. Okay. So now I have my categorical features, the list of my categorical features, which is in this case ocean proximity. So I have my categorical features. I'm just curious about what type of, how many different or unique values my categorical feature has. So I'm just curious about that. So if you are also curious like me, right? So let's see, I'm going to pull or slice my data frame using ocean proximity. Ocean proximity. Okay, so I just took that column corresponding to ocean proximity. So what I'm going to do is I'm just going to see how many values of each category I have. Okay. Oh, here it is. So my data set has different types of ocean proximity values, like less than 1 hour to ocean or inland near ocean, whatever. And these are the data points or districts which have this value for ocean proximity. So again, these are details, but if you want to keep this indices as a list and these numbers corresponding to those indices as another list, so you can do all kinds of things. Okay, so it's up to you. I just want to show you that there are ways of doing this. These are minor details, but believe me, it's taking time. Okay, when you want to work on a project, these kind of things will take time to actually figure out. Does this hands-on ML book also cover ML serving and monitoring deployed models? I mean, there is a very small. It's talking about it, but monitoring deployed models. I mean, deploying and then monitoring deployed models is not discussed in detail, John. Yeah. Okay, so what I was talking, yeah, let me say, so A, so if I say A is this numbers corresponding to indices. So if I say A dot index, right? So now it is giving me the list of these the unique values. So again, if you like, you can simply turn it into a NumPy array and then later use it. Okay. So this is now the list of the unique values. Again, there are many different ways of doing this. I'm just showing you one example here. Okay, let's continue working on our data set. So housing, this time I'm going to see what is the minimum, maximum 25th and 50th quartiles of my numeric features in my data set. So for that, I'm going to use the describe method, which is a very important method that we are using for pandas data frames. Okay, so describe is going to give me, as you see, I have my numerical features here. So it's giving me how many of those features have actually values. So if we don't have any value, let's say there are missing values, they are going to omit. So as you see there, so we have 20,433 of total bedrooms values. That means there are some missing values there. So this is giving us some idea about what is the average, the mean for each of these numerical features, or the standard deviation, the minimum and maximum. So we are just seeing the big picture about our data set. Okay. Again, still exploring the data set. All right. So I also want to see my numerical features as a histogram. Okay. So you can create histograms for your numerical features. You can create bar graphs for your categorical features. So for in this case, I just want to see the distribution of my numerical features. So again, multiple ways of doing this. I'm going to be using PyPlot for that. You can do different ways. I do it in different ways, but I'm going to be using, oh, I already imported this one. So I'm going to use PyPlot. So housing is my data frame. What I'm going to do is I'm going to create my histogram. So if I do this, why is the count of total bedrooms less? Let's see. What do you mean less? Total, oh, there are some missing values, Amit. There are some missing values here. Total bedrooms have some missing values. They're going to take care of it in a minute. Okay, so housing hits is going to give me a histogram. It's going to give me a histogram. As you see, it's not very nice, right? So again, these are minor things, but it's going to create a problem for you. So these are all obstacles, right? So let's make this a little bit better. So first of all, let me create each of the histogram in maximum 50 bins. Okay, so I'm putting my, so I'm looking at my histogram in more detail, 50 bins. I think the default was 10. Second, the figures are small, as you see. So let me make them bigger so that I will see the figures better. So for that, I'm going to adjust the figure size. Okay. Okay, so the figures look much cleaner and better, right? As you see, small things, but they mean a lot. So there are a couple of things you might notice here. So some of the numerical features have double, in here, the distribution is not so symmetric, right? So it makes a peak in here, another peak in here. Longitude and latitude are similar. So housing median age is symmetric, looks like symmetric, but here we have some problem here. Probably this is because of censoring. The data might be right censored. In other words, there are some houses which have some, so their age, if it is exceeding a certain number, they are all counted as the same age, probably, right? And I think median income and median house value or number of households, total rooms, so they look okay. They look okay. They're not totally, symmetric, but they look okay. All right. So what? Why did we do this? Right. So we are trying to see if we need to make any transformations on these data sets. Okay. For example, logarithmic transformation. By the way, you're not going to do any logarithmic transformation if your data set has negative values for the information. You're not going to do any logarithmic transformation on a column if that column has any negative values. Okay, any transformations you need for these data for these features. That's why we are looking, and then we want to see how the features are distributed. The more normal looking like distribution, the better for us. Why? Because some of the models are making that assumption about the features, and those, based on those assumptions, the models are working. Okay. So we want to maybe, bring the distribution of the features as close as possible to normal distribution, if we can, by some transformations. Okay, so let's continue. Let's continue on looking at our data set. So another thing I want to do is, at this point, is I'm going to split my data set into two pieces: train and test. Now, this is one of the things I observe over and over again when I work with like the data scientists or students learning data science. So they make the transformations first, and then they split the data into train and test data sets, which is wrong. Okay, which is wrong. So you need to first split your data into train and test, and then start doing your transformations on the training data set. Because test data set is representing the data set that will be coming from the real world. Okay, so you're not going to be receiving data sets already transformed. That's not gonna happen. You are going to transform them, right? So then how can you transform new data points coming from outside world? You're going to transform them based on with transformations that you already trained on your training data set. So we are going to split our data set into training and test, and then we are going to train our transformers on the training data set. And we'll use those transformers or transformations to transform the test data points. All right, so now what I'm going to do is I'm going to split my data into train and test. It's very easy. Splitting data set is very easy, but let's do this manually first, just to see what happens when you split. Why I want to do this? Do not please split your data set automatically for any case, all right? So for some cases, like time series data sets, we are not going to shuffle the data points and then split them. That's gonna totally ruin the time dimension of our data set, right? So by the way, we are gonna have a time series workshop in a couple of weeks, if you have received the emails, right? We don't wanna do that. So, or it may not be a time series data set, but there might be some relationship between each consecutive data points. It's not a time series data set. For example, you are taking measurements on a material after you remove a tiny bit of surface from the material and making some measurements, right? So it's not a time series data set, but there is a certain order in terms of how the measurements are taken. So you cannot simply shuffle this data set and then split it. So be very careful when you make this decision on how you split your data into train and test. You have to know in which context the data was collected. So let's see how train and test split is happening manually. And then let's do this using scikit-learn with one single line of code, train and test split. So for that, I'm going to write a function, and then we're going to write this function together. And then please help me if I make any mistake here. Okay. So I'm going to write a function, and this function is going to split my data set. So let's say split. This is how I call my data set. You can call it whichever way you like. I'm going to split my data into train and test. The input to this data set is the data itself, okay, the data itself and the test ratio. So I want my data to have 20% test data points and 80% of my data points as training data sets. So you can adjust this test ratio, right? Okay. So now, given these two parameters as the inputs, I'm going to take my data and then split it into training data. So for splitting the data sets, I'm going to create a random shuffle of indices. So how many data points I have? Let's say, I have this many data points. Let's say 1,000 data points. I'm gonna create 1,000 indices and then shuffle those indices. So for that, I'm gonna be using NumPy's random packet, and then random comes with a method called permutation. You know permutation, right? If I give you 5 numbers, you can create 120 different permutations of these 5 numbers, right? So we are going to randomly shuffle the indices and then create a random set of indices. So for that, shuffled indices, NumPy random permutation. Okay, what are we creating here? I'm going to use the length of my data. Well, I think this also works if your data is an array, like a 2-dimensional array or data frame. It has 2 dimensions, right? Number of rows and number of columns. Here you need to focus on your number of rows. So you can also, I think you can also use data.shape 0. 0 will be the first element of that tuple, which indicates how many rows and columns you have in your data set. Okay, so I've created this shuffled indices. Now I'm going to be using these shuffled indices to create my test and train data set. So test size, okay, is going to be this many. I'm going to turn, first of all, the length of my data times, I'm going to multiply my length of data times this test ratio, okay, and then turn it into an integer, okay, because I don't want 500.5. It doesn't mean anything, right? So it has to be an integer. And then I'm going to do the same thing for my train data set size. I have the test set size. So what I'm going to do is now I'm going to find the test indices. Test indices, sorry. We'll be done with this in a minute, okay? I just want to show you how we can do this manually. Test indices, I'm going to take the shuffled indices and get the first test set size, okay? So what happens here is, let's say you have 1,000 data points. This shuffled indices is a shuffled 1,000 numbers. Like, so for example, the first number is 120, the second number is 110, the third number is 1. So it's totally random indices, but the set contains 1,000 numbers. Here you are taking the first, let's say 200 numbers, because your test ratio is 20%. First 200 numbers, first 200 indices, 200 indices are for the test data set, and the rest are for the train data set. Okay, just it's the training indices. From test set size and then forward. Okay, so we actually created our test and train indices, and then I'm going to return test data set and train data set. So data.ilog, you know, I'm using ilog to specifically refer to a row using the index number, right? So train indices. Okay, and similarly, test indices. Let me copy this. I want to show you something after this one, test indices. Okay, perfect. So we got the function, and then let's run this. Okay, so here is my train set, test set. Okay, split, train set, and then this is my data set, housing, and this is the test ratio. Hopefully it will work. And it didn't split train test. And then another shuffled indices. Okay, so we got the train and test data sets, and then let's check the length of train data sets. Okay, 16,000, 80% of our data sets are okay. At this point, this train set and test set have all the features, including our target variable. Please keep that in mind. Okay, now I'm going to do the same thing using scikit-learn, and it's, as you see, it's going to be very simple. But before getting into that, let me just print the first 5 observations of my test data set. And another thing I want to do is I want to set my random seed, okay, before this step. Let me set my random seed. There's a reason for why I'm doing it. In a minute, you will see that. Okay, I set my random seed. Now I'm running this one more time. Okay, so setting the number seed tells my machine that every time I run this code, pick, in this case, the third random number sequence. So every time I run this code in my machine, I'm going to get the same random numbers. In other words, I will always get, given this random seed, the same observations in my test set. Okay, that's why I did that. Now let's do the same thing using scikit-learn. Okay, for that, I'm going to say from scikit-learn, model selection, import, train, test, split. Okay, so I'm going to split my data set into train and test data set. Train, set. Well, scikit-learn allows you to split your data frame into train features, train label, test features, test label. But we want to just here compare my function with train test split. So I'm not splitting my features into feature and target variable at this stage. Okay, is equal to train test split. So this is my data set. And this is the test size. And also random weight is 2. Okay, let me go to the next line so you can see it. Okay, so I'm using the same random seed that I use for my function. See 2 and 2. So let me run this. And then what I'm going to do is I'm going to do the same thing like test set head. Test. So as you see, I have the same indices. Okay, so the reason is I set the random seed to 2, right? For both cases, I got the same data points appearing in test and data set. Regardless, you are using your own function or scikit-learn's train test split. Okay. Oh, by the way, if you are asking questions, I don't know, please share the link to the data set and notebook. Sure. Just 1 second, I'm going to share it. Somebody already shared. Thank you. Orhan already shared. So should stratify be used here for splitting data? So Charles, stratification should be used if your target variable is discrete. In other words, if you are working on a classification problem, you should use stratification. In other words, when you are splitting your data set, you should split the data set, observing that at each split, you have the equal ratios of the target variable. Let's say you have a data set, 1,000 data points, 100 of them are, 100 of them are professors, 900 of them are students. Okay, there are 1,000 people in your data set, 100 professors, 900 students. So when you split this 1,000 data points into train and test, you want to have the same ratio. What is that? 90% students, 10% professors in the train, 90% students, 10% students in the test data set. So if this is a classification problem, let's say you want to see who is professor, who is a student, you want to predict that, right? So when you make train test split, you're going to use stratify equals the target variable when you're using train test split of scikit-learn. Now, I'm going to show you today that not only the target variable, but you must pay attention to some of the features. If the client, your client told you that, you know what, this feature is extremely important based on our experiences, it's extremely important. And by the way, you can also maybe see that by looking at the data set. That variable is extremely important in terms of predicting the target variable. And that variable is continuous, or it can be, what is it? Let's say that variable is continuous. And you want to have the same kind of distribution in both your target, train and test data set. For example, median income is a very important variable for a district in terms of predicting average house price in that district. Now, when I split my data set into train and test, I want to have a similar distribution of median income in both train and test data sets. This is very important. If you don't pay attention to that, highly probable that you're going to create a biased split. So your train and test data set will not have the same ratio as your overall data set, right? So how can we address this problem? I'm going to share a couple of things with you in a minute, okay? So just be patient. Yeah, random seed. Yeah, notebook is not there, Alvin. We just began to write the notebook. It's not there, so I can, after this class, I'm going to add this notebook into that folder, okay? So again, for random seeds, when computers are generating random numbers, these numbers are coming from some sequence of random numbers. So imagine that there are a number of columns. Imagine a big table, okay? And the first table is seed 0, the second table is seed 1, seed 2, seed 3, seed 42, seed many. So each column is giving you a different sequence of random numbers. It's a little bit counterintuitive. How come we have a preset sequence of random numbers when we are generating random numbers? I understand that. But the beauty is when you are conducting an experiment, or like this, when you are splitting your data into train and test randomly, and next day or next time when you run this code or somebody else running this code, you want them to get the same result, right? Because for decision trees, for example, splitting the data set, how you split it might be extremely important. So then you want to use the same random sequence every time so that you can, replicate your study. So that's why setting the random seed to a number, that means I'm using this column of random numbers this time, is going to help you to generate results every time you run your code in your machine. Okay, so let's continue. So what we did just now is we tested our function for splitting our data into train and test, and also we tested scikit-learn. Now we have a better understanding of what happens when we split our data set. And we just noted in here that for time series data sets or for some other data sets, if the consecutive data points have some kind of a relationship, I'm not going to use this type of train and test split because it's going to take away that relationship. Time as a dimension in time series data set is important, extremely important. That's why it is time series. The moment you make this kind of a split, you're going to lose time in your data set. Okay. So what I'm going to do is, somebody told me that the median income in my data set is very important. So people in the field, right, your client, already has some experience and says, you know what, based on median income, you can have a very good idea about what is the average house price in that area. So then you are going to pay special attention to this feature. Let's just, we already saw the histogram of this feature before, but let's just look at this variable one more time. So I'm going to create a histogram of median income. Okay, they're very simple, not too much. We just plotted the median income. So again, this is the number of, districts with this median income. So these numbers like 2, 4, 3, 6, probably corresponding to some bigger numbers, right? 60,000 or maybe 600K. So I don't know. I don't think there is districts with this average of, I don't think this is 1.4K. I don't know, but these numbers are telling us something about that the income is it's not totally symmetric. Okay, so if I split my data set randomly, it's very probable that I am going to have a different distribution of median income in both train and test data set. all right? It's possible. So then how can I address this problem? How can I address this problem? Yes, Sunshine, I'm going to, we are going to post this recording at YouTube channel later. So what I'm going to do now is I'm going to create a new variable from this median income. And this new variable, you're welcome, this new variable is going to be actually dividing this histogram into bins, okay? So I'm going to actually deliberately, I'm going to create a new variable, which is going to represent this continuous median income variable like a categorical variable. So I'm going to create a categorical version of this median income. So what I'm going to say is housing, and then this is going to be income categorical, okay? So from time to time, we do this. From time to time, we actually turn continuous variables into categorical variables. Please be careful about that too, all right? So when you turn a continuous variable into categorical variable, all right? So how can you turn a continuous variable into a category? Let me give an example. Let's say age. Age is continuous, right? So age might change from, let's say in your data set, 10 to 80, right? So, and then you suddenly say, you know what? I'm going to turn this age into a categorical variable with two categories. What is that? Senior and junior, or young and senior, okay? And then let's say young is 60, all right? Anyone less than 60 years old will be considered as young, okay? Let's be generous today. So then what can you do is age less than 60 is young, age greater than 60 is senior. Then 59 will be young and 61 will be senior, right? So you understand the problem, right? So creating categorical variables from continuous variables might be problematic as you approach to the threshold value from left and right. But our concern here is a little bit different. We are not going to totally turn our variable into categorical. We are going to use this categorical variable to split our data, and then we'll get rid of this categorical variable. We are still going to use the continuous variable in our analysis. Okay. So what I'm going to do is I'm going to use pandas cut method, and you can check for each method. You don't have to memorize everything. We don't have to know all these different methods, but let us know that they are out there. So you can check what this cut does. Actually, it takes a continuous variable and it cuts into bins. So what I'm going to do is I'm going to cut my housing median income variable. So this variable, okay? I'm going to cut it into bins. Okay, what kind of bins? So let's now define the bins. So bins are going to be anything from 0 to 1.5, okay, is one bin. And then from 1.5 to 3 is going to be another bin. And then 3 to 4.5 is going to be another. I'm just looking at my data, okay? Anything from 0 to 1.5, 1.5 to 3, 3 to 4.5, 4.5 to 6, okay, 6. And then anything beyond is another category. All right. So again, how did you decide these numbers? You can try different numbers. By just looking at this number, most of the data points are changing from 0 to, I don't know, 6, most of the data points, right? So because this is a right skewed data set, right? So it's a right skewed distribution actually. So most of the data points are between 0 and 6. So that's why anything beyond 6 and infinity is really high median income. Okay, so these are the bins, and let me go to next line, and I'm going to assign some labels to them. Okay, again, these labels have nothing to do with these numbers. So these numbers are representing the values of median income. These labels you can assign, integer values. You can assign strings. It's up to you. So I will assign, a list of numbers: 1, 2, 3, 4, and 5. So I am creating 5 different categories from my income: 0 to 1.5, 1.5 to 3, 3 to 4.5, 4.5 to 6, 6 to infinity. There are 5 different categories. So let's hope that this is going to run. And yes, we created our categorical variable. Now let's count how many values within each category. Okay. So as you see, a few number of districts have, where is it? 5. So a few number of districts actually on the left-hand side, right? So from 0 to 1.5, not so many. And from 6 to infinity, the fifth category, 2000. But most of my districts are actually belonging to categories 2, 3, and 4. That is the bulk of my data points, okay? This center here. All right. So why did we go through this painful operation here, right? So we are going to use this. Actually, let's also create the histogram. Housing, income category. Again, just for the sake of checking how it looks like. This is the histogram. Again, these are 5. Now, these numbers have nothing to do with these numbers. Don't be confused, all right? So these numbers only indicate the index number, okay? When I say index number, the categorical values. All right. So this is my new categorical variable. Let's think how we can use this categorical variable to split our data more meaningfully than we split it into train and test data set. For that, what I'm going to do is I'm going to use scikit-learn's stratified shuffle split class. Okay, so from we'll see the use of that class in a minute. From scikit-learn model selection. Okay, I'm going to be importing the stratified shuffle. Now, from very simple looking problems with a few features, this data set is not a big data set. Okay, you can create really, sophisticated models. Your problem later on, as you work on the data set, you might realize that, you know what, this at first looked very simple, but it's not actually simple. There is so much to do on this data. You will experience this on many different data sets. Okay, please do not take it lightly when you see a data set with a small number of features. It may get really complicated as you begin working on it. Okay, stratified shuffle split. What I'm going to do is, with stratified shuffle, I don't know, I'm pretty sure that you know about cross-validation, right? You know about cross-validation. We are using cross-validation to see if our model is overfitting, which I will use cross-validation. You will see the implementation of cross-validation to check if our model is overfitting when we are using decision tree models. We'll see that as part of this workshop. Now, with cross-validation, we do this stratified shuffle split. We take the data set, we shuffle it, right? We shuffle it, and then we divide it into, splits. And then we may shuffle it multiple times. Like if your cross-validation is a cross-validation CV equals 10, we are shuffling our data set 10 times, right? So here, if you are using shuffle cross-validation, here we are going to make one shuffle and then divide our data set into test and train data sets. Okay, so let's do and then see what happens. What I'm going to do is stratified shuffle splits. Okay, so what I'm going to do is I'm only create one split. Okay, I'm going to do this one time, and my test size will be what, 0.2. Okay. And let me go to the next line so you can see it. And then let me set my random state. Okay, so let's make this equal to a variable split. Now let me run this first and then see if it number of splits. Sorry about that. Okay, so let's see what split looks like. So as you see, split is just right now it's an object. It's not giving us any information. It simply says that split is something that takes in whatever the data set you have shuffles it once, uses this random state of 2, and then divides the whatever you want to divide into 20% and 80% groups. That's all. Okay, that's what split does. All right, let's use this split to split our data into train and test. So what we're gonna do is, I am going to use this split in a for loop. Okay, that is how we use. Again, please check stratified shuffle split manual from scikit-learn, which scikit-learn has really good, rich, and then easy to follow manual. Stratify. So I'm gonna say train index and test index. Okay, so train and test indices will come from this split object as long as I give my data set into it. So split, in. So I take this split, split this one. So split is an object. I'm going to use its split method. So let's also check that if it's gonna work. So it is not going to, it's going to require a data set. So it is missing 2 required positional arguments, X and Y. X is my feature set, and Y is my, in this case, my target. So in this case, instead of target, I'm gonna be using income category. So what happens here is, based on income category, split my data into train and test data sets so that these categories are equally represented in terms of ratios in both data sets. That's what's happening, okay? So split my data, which is housing, okay? But when you split my data housing, which is X, use housing income category. Okay, let me go to the next line so you can see. All right, so split my housing data sets based on income category. Okay, okay, so now this is going to return the indices of the train and test data sets, test data points, similar to what we did in this function here. Indices. I'm just finding these indices here. Now I'm going to use these indices to create my train and test data set, but this time my data sets are stratified based on not the category, not the target variable, but one of the continuous variables that I have in my feature set. Okay, stratified train set is my housing data set, which is using this train indices. Okay, I'm going to use the same thing for my test data set. Okay, and then let's see if this works. If you posted anything in the okay, so I just saw that you posted some things on the question and answer. Housing median income train test 3.54, 3. Are very close. Yes, Edward, they're very, very close. But we'll see that, can we make this even better? Okay, that's what we are trying to do. Okay. In this case, it may not make too much of a difference. I agree with that. Are you guys tired? Should we give a short break now? Okay. All right. So my time is 1:06 here. Let's meet in 9 minutes, okay? 1:15, right? Past 15, I'm gonna be back. Please be back, all right? All right, so let's continue. Let's be done with this train test split. I see Harper's comment on why don't you just use train test split and stratify equals housing income category. Exactly, you can use that one too. So I just wanted to get a little bit, just open it up. So yeah, you can use that one too. Let me just type it here. Train test splits, and then it's going to be housing data set, and then stratify. This is from scikit-learn. Those housing. I generally use this for classification problems when I want to split data based on the target variable. Here, instead of target variable, you can income category. So this will also give you the same result. Okay, so let's do one more thing with this, and then start working on our what is that visualization of our data set. What I want to do is, because we spent so much time on this train test split and then stratification, just to check what is the impact of this stratification on splitting our data set. That is the first question. And second question, which you should ask yourself and then maybe look for an answer. What if you want to stratify your data set or split your data set based on multiple features? So is it going to be easy to do that? For example, in your data set, you have a log of users using different devices. Some of them are using iPad, some of them are using web application or iPhone. And then you have users with different age groups, and you have users from different parts of the world. Let's say you categorize them as English-speaking, non-English-speaking countries, right? And what else? And then you have gender, right? So now you want to create a test and train data set, but all these four different features are extremely important, let's say, okay? Then how can you maintain a similar ratio of each of these categories of, features in both your train and test data set? So this is some question maybe you can think about. If you have more than one feature, then what should you do? Before moving into visualization of our data set, let's focus on what is the impact of this stratification on splitting our data into train and test. So for that, let's just create a very simple function, which is going to give us the ratio of certain category in our data set to overall data set. So I'm going to say income category proportions. And this is going to take in data as the parameter, okay? Parameter value. Income category proportions. What it will return is, it's going to take in my data and then pick the income category feature and then simply take its value counts. We know what value counts does, right? From each category value, how many of that value is repeated in my data set, and divide this by number of data points. That's it, okay? That's what this function does. Now I'm gonna use this function to check the impact of this stratification on my train and test split. So I already split my data into train and test before, but let's remember one more time here. Let me just bring it over here. Okay, so this is my train and test split. All right, so this is what I have already. So what I will also do is, let me run this. I'm going to now compare this train set with this stratified train set with the overall data set. So I'll compare the proportions. So I'm going to create a data frame, okay, PD data frame. So this data frame is going to have 3 columns at first. First, overall. Okay, let me put this in a dictionary. Make this capital. Okay, so this is my overall. What I'm going to do is income category, proportions. Yeah, housing. This is the overall data set, right? Next, the next line. So this is just entire data set. It's giving me the fractions of different income groups in my overall data set. Next, I'm going to do the same thing for the stratified group. Let me close this parenthesis, by the way. Stratified. Okay, so for this, instead of the entire data set, let me just use the test data set. This one. This one. Okay. And next, comma, for the next line, I will use my random one. This one. Let's call this random. This is coming from my train test split, which is directly from scikit-learn. Okay, this is test set. Okay, let's run this. Okay, I got my okay, so this is my overall. There are five categories, and these are the ratios of each category within each group. Again, this is the entire data set, this is stratified test set, this is the random test set. So there are some minor differences. Let's see how minor those differences are. For that, what I'm gonna do is I'm gonna compare this data frame. I will take the random. I'm gonna create a new column. Let's call this random percentage error. Okay, and this is equal to, I will be very quick writing this function, this equation. So what I'm going to do is I'm just going to subtract random from overall. I'm trying to see how different stratified and random from the overall data set. I'm just going to subtract random overall from random, divide it by overall, and then see how different in terms of percentage random is from overall. That's all I'm going to do. Okay, nothing fancy here. So what I'm going to do is compare problem. I'm going to do some copy and pasting here so that it's going to be faster. I will take the random first, and then I will divide this by overall. Okay, let me take this to the next line that you can see what's going on. So I divided this and then close the parentheses. So basically, I just want to see what is the percentage of error. So I can subtract from this, I can subtract 1. Okay, so let me copy this. I'll be done with this in a moment. This time, instead of random, I'm going to use stratified error, percentage error. Again, instead of random, I'm going to be subtracting from stratified. Okay, I think we are done. Okay, let me print this. So, as you see, this is the percentage errors. How much of random is different than overall? How much is stratified different? As you see, sometimes there's a big difference, right? So this is 6.2. If you compare these numbers with the errors that we have with stratified, the stratified error numbers are extremely small. So we just wanted to make a point here, right? Again, please ask yourself, what if you have multiple features and then you want to create a split data set into 2 groups? I mean, I did this manually before for different data sets. It's extremely time consuming and then, I mean, you have to be careful. But what if you have multiple features and then you want to create a train and test data set, stratified train and test data sets? All right, let's continue. Let's continue with the visualization of our data set. Now, what I'm going to do is I'm going to take my training data sets. So let's say housing. This time I'm going to use the word house for my data set. I'm going to take my stratified train data set. Just copy it. Okay, that is my train data set. Housing is my entire data set. This is my train data set. Now I'm just going to plot so first of all, let's remember what we had in our data set. So these are the locations, you remember, longitude and latitude of our districts. So let us now print these our data points based on longitude and latitude, okay, on the screen. Okay, let's do it. So I'm going to take my data, and then I'm going to just create a scatter plot. Plot, what's the kind is scatter. Scatter plot of what? On the x-axis, I have latitude, and then this is on the y-axis. On the x-axis, I have longitude. Okay, so x is this, y is this, and then let's create our scatter plots. Let's see what we're going to see. So those who are familiar with California, state of California's map, this actually is giving you a blueprint of California map, right? So these are the data points in our data sets. Each of these dots are representing data points, and I am printing my data points based on their values in longitude and latitude columns. That's what I did, right? And this gives me a nice California map. So let's now try to work on this representation a little bit more, try to get some more meaning from the data points. Okay, so what I'm gonna do is, instead of just plotting creating the scatter plot of my data points, because some of the data points are falling on top of each other, overlapping, right? So as you see here, I don't see individual data points, but a cluster of data points. So it might be the case that some of these locations have so many data points on top of each other, and here a few of data points on top of each other. So I don't see the difference between very intense areas versus less intense areas, but still overlapping, right? So I don't see that difference. So for that, I'm going to use the same line, but this time I'm just going to add one thing, which is very simple, actually. So what I'm going to do is I'm going to say alpha equals 0.1. So this alpha is determining how actually when you print this color, the intensity of this color. So it's going to be less intense. This color is not going to be dark blue. It's going to be very light blue. So that I can see really areas where there's lots of data points clustered versus areas where less number of data points clustered. So here we can see that very clearly, right? So there are some regions where really we have intense data regions, right, in our data set, and there are some regions we still have overlapping data points, but they are not as intense as these areas. Okay, so what else can we do? So let's think about it. Let's try to do a little bit more instead of just the intensity of the areas, like in terms of districts. So can we also reflect the price, right, on this graph? So the answer is yes. Let me just copy this. Okay, copy this, and then what I'm gonna do is, let me go to the next line. What I'm gonna do is I'm going to assign here, letter S is going to be representing the population of these places. If the area is highly populated, means there are a lot of people living, the circle is going to be large. If the area has less number of people, the circle will be small. Again, remember, each circle here is representing one data point. As of now, they look all the same as in terms of size. Now I'm tying the size of each data point, which is represented by a circle, to the population of that district. So what I'm going to do is I'm going to take the housing. So I am going to use population. Okay, let's divide this by 100. Okay, so that I'm just scaling the number down a little bit. And then let's see if this is going to make any difference. Okay, Let's see if this is going to make any difference. Forgot a comma in here. Okay. Now, there are some regions where we have a large population of people. There are some regions where we have smaller population of people. Okay. So the circle size is reflecting the population. So can we do a little bit more on this? The answer is yes. What if I also want to show the prices? Okay. And not only how intense the areas are, the districts are close to each other, and then how populated those areas are, but on top of that, how pricey those areas are. So in addition to what we already have, right? So let's also add the house price. So another variable, C is going to color, okay? C is going to color these circles based on the price. So the higher the price, again, depending on what color map you choose, the higher the price, the more the red, the color will be reddish. The lower the price, the blue, the color is going to be, the more blue. So for that, I'm going to be picking the color map as jet. So depending on what color map you choose, you can map that color to the price, whether it's high or low price. So C is going to be the median house value. Okay, and then let's pick CMAP. Okay, so there are so many different ways you can define CMAP. Okay, so I'm using pyplot get CMAP jet. Okay, all right, so let's run this. Now the color map is showing us which areas are actually more expensive, which areas are less expensive. As you see, as you get closer to coastline, like this is Bay Area, here the Bay. So this is, I think, the Silicon Valley area. This is Los Angeles area. So you have higher prices, right? So let's change this alpha to 0.4. So it's going to give us make the colors brighter. Okay, I think this is a very good map now. So let's also add the labels so that we know what is what. So what I'm going to do is label is population. So I mean, we're going to see in a moment, and then you can also adjust the figure size. Let's adjust the figure size too. Figure size was actually 1/10. So, okay, perfect. Right. So this indicates the population, and this is the circles are indicating the population. The colors are indicating the price. Right. You can even print the what is that? I can even print the. Hold on. Let me see. It's gonna make a difference. Making a difference. I was just trying to plot the price in here. Couldn't get it. Anyways, I couldn't get the price plotted. If you could, please let me know. Okay. I couldn't get the price plotted. So this is indicating the price. This color map is indicating the price. Okay. So next step is if you want to impress your client. Okay. So yeah, your client can understand that this is California picture. What if I want to put the California picture underneath and then place my data points on that map, so that on the map, actual map, the client can see how my data points look like. Okay, so far we didn't do any machine learning, nothing, but this is going to be very useful in terms of communicating with your client. All right, so let's, I think I need to, I'm going to try one thing. Maybe I need to print the legend. Yeah, to that legend. Let's see if this is going to work. No, okay. Anyways, all right. Let me see if you have anything. Why you use stratified shuffle speed instead of the one of the other cross validators. It's going to be very, Frank, it's going to be very confusing because cross-validation is one class. Inside cross-validation, you are using CV. You can define CV outside cross-validation, like k-fold, stratified k-fold. Here we want to obtain the indices of the shuffled data points. I didn't try this with stratified k-fold or k-fold. It might work. It might work. I didn't try it, Frank. So maybe you can try. It might work. Maybe after this class, I can try it myself too. I'm not sure if it's gonna work or not. But cross-validation itself is one class. Okay. Inside, you are defining how you are going to fold the data points, how you're going to split the data points into different folds. You can define that outside cross-validation, as I said, k-fold or stratified k-fold. And then inside stratified k-fold, you can introduce shuffle. I think this stratified shuffle split is doing exactly the same thing with stratified k-fold in parentheses, shuffle equals true. I think that is exactly the same thing as stratified shuffle split. But I didn't check it myself before. Okay, so now let's print the what is it? Map. I just went blank for a while. Okay, before doing that, I want to adjust this image. I want to adjust it a little bit of how the X and Y axis limits are changing. Okay, let's make that adjustment so that we can bring in the picture of the state of California's map. Okay, so what I'm gonna do is I already have my I already have my data points on the scatter plot. So I'm gonna do a couple of things more in here. What I'm gonna do is I'm going to print the Y label so that I know what Y label is. Let's do this. Okay, this is my Y label, and then let me also define the font size. Let's do the same thing for the X label. So these things take really time, all right? Doing all this work takes real time. I don't want to just jump from one point to the next point and then magically you have something. I think we should go step by step and then really learn what is happening here. Longitude, and then let me latitude, X label. Let's mix these two, Y label and latitude. Okay, so let's see how this looks like. Okay, now we have the labels, right? Latitude, not longitude. Okay, in addition to these labels, I'm going to add, top of that, I'm going to add some tick values so that here on this bar graph, I'm gonna put the tick values. It's gonna look much better. So let's do it. So I will first define a variable called prices. So this is taking my house prices. Okay, so if you run this, it's not changing the graph at all. What happened here? Oh, that's not housing, house. Median house values, median house value. It's not values. Okay, so if you see that nothing is changed because I'm not using this variable yet. So if I say prices, you will see a list of prices. These are all the prices of the houses in my train data set. So I take that prices. So from these prices, what I'm gonna do is I'm gonna take the minimum of the prices. So this is prices. So if you say minimum, it's gonna give the minimum of the prices. Okay, I'm gonna take minimum of the prices. Okay, so in between minimum and maximum, what is the maximum? Here is the maximum of the prices. Okay, so this is the maximum of the prices. I'm going to take prices maximum. So in between minimum and maximum, I'm going to create this. You see this graph, the bar. This bar is representing the prices. So I'm just going to change a little bit of these numbers. That's all. Okay. So what I'm going to do is I will assign a new variable called tick values. These tick values are going to be using the numpy's lint space. I'm going to equally space ticks in between minimum and maximum prices. All right. 11 of them. So let me see what happens when I run this. Now, tick values. You see, I just spaced the prices from minimum to maximum. There are 11 intervals. Okay, there are 11 intervals. So these will be representing ticks. Now, you will see one thing, and then you're going to ask me a question, but no worries. So you can find the answer if you just search for it. Okay. So what I'm going to do is I'm going to be using these tick values to make my this bar over here. Okay, this bar over here. I'm just going to change the tick values. So let's do it. So what I'm going to do is, first of all, I'm going to create my bar, this bar here. Okay, so it's going to be plt dot color bar, and this bar has the ticks of tick values. Okay, divided by the maximum of the prices. So instead of typing 500K, I'm just going to normalize it by the maximum of the prices. Okay, I just had an error here because there is no color, color bar. I have to add using prices. 1 second, let me find the error here. Let's see, color bar in ticks is this. Okay. All right. So I need to first create the color bar. So here I'm going to assign this X, and hopefully. Okay, there's a small error here which I cannot see. If you can see, let me know. But my goal was creating a color bar here, which is changing from a scaled price from minimum to maximum. These ticks will be representing the prices. So let me just cancel this out. Let me just cancel. It's not very essential. Let me just cancel this out. When I find the error, I'm going to correct it and then share this folder file with you. Anyway, so it's not so essential. Let me run this here. So this is my data set. Now let me add the California image onto this data set, okay? And then let's move forward. Okay, so what I'm gonna do now is I'm going to take my California image. By the way, where is this California image? I shared it with you. So let's first bring this into our platform. So the California image is somewhere. I think I shared with you. So you can see it from in the folder that I shared with you. So what I'm going to do is I'm going to use MP image, and this MP image is coming with matplotlib. Let's import it. Image as MP image. Okay. So I'm just reading an image. There are so many different ways of reading an image from your folders. This is just one of them. Okay. So I'm just reading an image. Okay, from my folder. So you please you make sure that you type the path correctly. Here, this is my path, but your path can be different. Okay. ENG. Okay, I got my California image. This is net. All right. Next thing is what I can do is I can actually print this California image on the screen. So let me do it. Let me just show you how it looks like. Let me show. Okay, I'm just showing that image on the screen. So this is my California image. So you see on the X and Y axis, these are actually indicating the there are this many pixels, this one, like 600 times, I don't know, 700 pixels in this image. Okay, I'm just going to reshape this image so that I can put my data points on this image. That's what I'm going to do next. Okay, so what I'm going to do is take this image and then I will extend it. Means I'm going to change the shape of this image. I'm going to stretch this image a little bit so that it's going to fit on this data set. Look at this data set. It is changing from, say, negative 124 to negative 114, or changing from, I don't know, 33 to 42. So I'm going to bring the axis, numbers on the axis, X and Y axis, to the same range so that I can put these two images on top of each other. Okay, so that's what I'm going to do. Okay, so let's do it then. I'm going to extend my image to these values. So negative 124, that you can say 55 or just 124 might work as well, but I am taking here negative 124.55 in here, from negative 124.55 to negative 113.80 or negative 114. Okay, I'm just extending my image, negative 113.80. Now I'm going to go to top. It is what, 32, so here, from 32.45 to 42 some, okay? 32.45 to 42.05. Perfect, okay, now let's see how the image looks like. As you see now, the image a little bit stretched, right? The shape is still there, but it's a little bit stretched. Now what I'm going to do is, let me make this image a little bit, what is it, to tune down the color a little bit so that it is not going to overwhelm the data points. Okay, here is my image. Now I'm going to take this image and then put my data points on this image. That's what I'm going to do. Okay, so let's copy this. I'm just going to copy this and then bring it over here. Sorry, guys, this is taking a little bit longer than I expected, but anyway, so it's not so easy to do this kind of a work step by step. As you see here, now I have my data points nicely plotted on my California map, all right? So I can see what is coastline now, what is inland, what means proximity to ocean, or so it makes all sense by just looking at this this plot in here, right? So it tells a lot of story, actually, a lot more about our data set. Which areas are more pricey, which areas are more crowded. So we can see all that from this single picture. I think it's very, very important. I spent some time on this because I believe this part is extremely important to visually communicate what your data is telling you, the story of the data set. All right, let's continue. Next, after we visualize our data set, now we know a little bit more about our data sets. We know that room numbers and population and median income are important. We figured that out. We split our data set into train and test. We did stratification, and then we visualized our data set. Now let us find out which features of our data set are actually correlated with our target value. Okay, so that is the next thing. So for that, what I'm going to do is I'm just going to find the correlation in between the features in my data set. So a couple of things I want to point out here. Remember, house is my data set, training data set. If I simply say correlation, it is going to give me some, it's going to give me the correlation matrix, but it's giving me some, warning. So don't be surprised if you see warnings. When you run your code, you may not have a warning at first. A couple of months later, you come back and run the same code, you're going to see warnings, because these libraries are not just static. So, right, people are working on these libraries, improving them, making some changes. As they make these changes, some of the features are replaced or improved. Some new parameters are introduced. So before they actually establish those changes, they begin to give us some warnings. Here they are giving us a warning. They are telling us that, you know what, this house data set has numeric and categorical variables. When you find correlation is going to give you only correlation between numerical variables. In the future, make sure that you only enter the numeric variables instead of categorical variables. So that's what this correlation, warning is about. So then let's find the numerical features first, and then find the correlation among these numerical features. What I'm going to do is, as I did before, and for categorical features, let me just find it. I think we did this somewhere here. Don't want to take your time to type. Yeah, here. So instead of categorical features, this time I'm gonna use the same piece of code to create numerical features. Okay, here. Instead of categorical, numerical. Okay, features in house, say house, columns, and then house feature. This is not equal to, right? If it's not equal to O, then it's a numerical feature. So here we got the numerical features. So numerical features, right? So this is the list of the numerical features. Now, what I'm gonna do is I'm gonna do the same thing, correlation, but this time only the numerical ones. Okay, house. What I'm going to do is I'm gonna take the numerical features. And it gave me, again, a warning. So hold on. Oh, I have income category as what is that? Numerical feature. So I see. So let me get rid of the income category. Now, income category is income category is not a numerical feature, so that's why we need to drop it. I think we need to drop it. Yeah. Hmm? Okay. Okay, so hopefully it's working now. We got rid of the income category, and then we don't have the warning now. So again, small things taking too much time, right? Unfortunately, that is the nature of the work. Okay, so we dropped this income category. Now we got the correlation matrix. Let us sort the correlation in order, so that let's see which variables are actually highly correlated with what is that, our median house value. All right. So what I'm going to do is from the let me make this equal to correlation matrix. I'm going to select this median house value row, okay, from this correlation matrix, and then sort it out. Okay. So let me do this one more time. And then correlation matrix. I'm going to select row or column. It doesn't matter, because this row and this column are, housing value are the same. Because it's symmetric matrix, right? So median housing value, median house value. Okay, I got this column. Now I'm going to sort it in descending order. Hey, what did I do now? So this is median house value. It is correlated 100% with itself. So as you see, our clients told us the useful, valuable information. They told us, remember, median income was very important. Yeah, actually, median income is the one that has the highest correlation with our target variable. And then comes total rooms, and then housing, median age, households, and then total bedrooms. So, and then some of the things like population is inversely correlated with the price. The crowded, what do you expect? The crowded, the higher the price. In this case, the crowded, the less price. But you need to be careful about that, right? But in this case, it says that the crowded the district is, the less price. Maybe the houses got bigger and more expensive, the less number of people living in the district, right? So longitude and latitude probably have to do with the location, right? Probably as longitude and latitude are increasing, you are going inwards, moving away from the ocean side. That's why the price is inversely proportional, right? So again, to me, the latitude is as almost 2 times more, is more important than, in this case, age of the house, latitude. So the location of the house is very important. That's what I understand from here. All right, so let's continue. We found the correlation matrix. What we're gonna do is, well, if you like, in addition to this, you can create the scatter plots of different variables with respect to your target variable, just to see how they are correlated. Sometimes correlations may not catch non-linear relationships. Correlations only catch linear relationships, okay? So given your target variable, if your feature is linearly going up or down, or linearly changing with your target variable, correlation will capture that. But if the relationship is non-linear, then correlation will fail to catch that. In other words, you will see that, oh, my correlation value is very small, like population here. Maybe the relationship between population and median house value is not linear. What it means, for less populated and highly populated areas, the house price is small, and for medium populated areas, house price is high. The moment I give you such a relationship, you see, this is a nonlinear relationship, right? Then this correlation value is not going to capture that important information. So that's why it's very important, guys. I see this over and over again, that just looking at the correlation matrix, we reach to conclusions about which variables should be dropped or left out. Please make sure that you also create scatter plots. Scatter plots will also tell you if you need to use any nonlinear features in your model. Maybe you're going to use polynomials in your model, so the scatter plots are going to be important in terms of conveying that message to you, all right? So let's create the scatter plot, and then I'm going to stop there. Again, I'm going to continue for a couple of sessions. I will do my best to get into details and then not omit anything that is so obvious. Things may not be so obvious for some of us, right? So we need to maybe learn as we move forward. So that's why I'll do my best to get into details. After this scatter matrix, I'm going to stop, but you're going to receive emails when the next session will be. And I'm going to put this file into the folder I shared with you. So next time you come, you're going to find everything that we did up to this point. So my goal is step by step, finish this middle part of the pipeline, go back, okay, which we should have done at the very beginning, but we didn't. Go back and then create the environment and more or less create the, make things ready for production ready coding, okay? And then come back, go to the end of the pipeline, but this time we are going to deploy the model. Okay, so hopefully in a couple of sessions, we are going to do all this. Let me create the scatter matrix, and then I'm gonna stop. For that, you can do scatter matrix in different ways, scatter plots. You can create scatter plots one by one. I will do this one by one. Actually, if I really want to see in detail what's happening and then think about it. If you want to see everything at once in a scatter matrix, if you have so many features, it's going to be pretty meaningless. There's so many small pictures that you will not understand anything. If you like, maybe you can selectively take some of the features and create a scatter matrix for that. So that's what I'm going to do. So from pandas, again, there are different ways of doing this. From pandas plotting, I'm going to import scatter matrix or matrix. Okay, and for these attributes, I'm going to create a scatter matrix. So median house value. Let me just copy this. This is my actually base, right? Median house value. Okay, and then go to the next line. I'm going to median income. And then maybe total number of rooms. Okay. One more. Let's take the age too. Okay, so these are the attributes that I will be using. Now let me create my scatter matrix. Scatter matrix, it's here. Okay, I already imported it. And house, I'm just going to select these attributes from my trained data set. Remember, house is my trained data set. So let's run this. And let's make this the figure size. As you see, figure size becomes important, right? Figure size by 12 by 8. Okay, very good. So here is the median house value. This is what I'm really interested in. And here's median income. As you see, median income and median house value are highly correlated, and there is a linear relationship. It's a linear relationship. So total number of rooms and median house value is also correlated. I mean, it's maybe hard to see from here. There are so many data points, but if you just follow this crowded area, right? So the more total number of rooms in a district, the higher the prices. It's almost linear. But when it comes to housing median age, there might be I mean, if you had divided this into bins and then take the average of each bin, maybe you might see the average of each bin moving upwards, so or downwards. I cannot say which way, but by looking at this graph here, by looking at this correlation, there is a very small correlation between median age and then median house price. So this figure also supports that, right? It's a very small correlation between house age and then house price. So I cannot tell actually confidently that as the higher the housing ages in a district, the higher the prices. I cannot say this confidently by looking at this graph over here. Okay, so let me stop here. Thank you so much for your patience, for listening to me. And please expect an email from us to schedule our next meeting. And these meetings may take maybe 2 or 3 more meetings until we are done with this project. And then hopefully you got some idea, if you are new into this area, you got some idea about how you can start working on your machine learning problems, given some data set. This was a very clean data set. Again, data set may not be so clean. It may not be so easy to get started with. So thank you. I'll see you guys next time. So take care. Goodbye.